Good job!
Now that we've tested all of our objects, let's look at our chart. Some of the objects floated and some of them sank. Let's see. The metal spoon and the penny sank. The plastic spoon and the stick floated. Is there anything that's the same about the things that floated and the things that sank?
Well, we know that the metal thing sank, and the metal spoon feels kind of heavy.
But so does the stick, and the stick floated while the spoon sank, so maybe it's not all about how much something weighs or its shape?
You're right, and that might help us explain why some things float and some things sink. The answer has to do with something called density. Everything, and I mean everything, is made of tiny particles that we can't see. And how dense an object is depends on how much space is between those particles.
Particles?
Jesse, what the quack is a particle?
Now that's an awesome question. Let's use our imaginations and pretend that particles are marbles. We'll start with a bunch of marbles on a table. If you had the marbles all right next to each other, that's kind of how the particles would look inside an object that's dense, like the metal spoon. But if those marbles were spaced really far apart, that'd be more like what the particles are like in something that's less dense, like the plastic spoon. The metal spoon is more dense than the plastic spoon. It's about the same size and shape, but the particles that make it up are closer together than the particles that make up the plastic one. But remember, everything has density, including water.
What?
It's true! Since water has its own density, if something is more dense than the water it's in, it'll sink. The metal spoon and the penny were more dense than the water, so they sank. And the stick and the plastic spoon were less dense than the water, so they floated. So will it sink or will it float? It depends, in part, on density.
Sink.
Float or sink?
Float.
Float or sink?
A submarine. Actually, a viewer named Sam sent us a question about submarines not too long ago. Submarines are kind of like boats, except they go under the water. And Sam wanted to know more about how they do that. And Squeaks does too. Well, submarines work because of the way things sink and float, and some really smart thinking. You probably know that when you put things in water, some of them float to the top and some of them sink to the bottom. We did an experiment to learn why things float or sink with our friends Bill and Webb. Do you remember that, Squeaks? We learned that whether something floats depends on its density, or how heavy it is for its size. If it's heavier for its size than water, it sinks. If it's lighter, it floats. For example, a plastic spoon isn't very heavy for its size, so it floats. But a metal spoon is pretty heavy for its size, so it sinks. That's how boats float too. They're really heavy. You wouldn't be able to just pick one up. But they're not actually very heavy compared to how big they are. They're not very dense, so they float. And submarines can float on top of the water for the same reason. But for a submarine to be able to go under the water, it needs some of that really smart thinking I mentioned earlier. To dive into the water, a submarine needs to become heavier for its size. It needs to be more dense. But it's not so easy to make something heavier when you're in the middle of the ocean. That's why submarines have big tanks called ballast tanks. When it's time for the submarine to dive down, the ballast tanks open up so they fill with water. Adding the weight of the water to the submarine makes it dense enough to sink. You can see how this works if you have an empty bottle or jar and a bowl of water. At first, if you put the bottle or jar in the water, it will float because the only thing inside it is air. It's very light for its size, so it's not very dense. But if you take the cap off and let the water in from the bowl, it will sink. The water makes it heavier for its size, just like putting water into the ballast tanks on a submarine does. The rest of the submarine is very strong and sealed up tight, so water can't get in, and so that if there are people on the submarine, they can breathe. To make sure they don't run out of air, they bring along extra air that's all squeezed together inside a bottle, like how you squeeze air into a bicycle tire when you pump it up. And then they can go exploring under the water, just like the people in the story Squeaks was reading. In real life, we use submarines for all kinds of things, including learning more about the oceans. When scientists send submarines under the water, they find so many cool animals. There are jellyfish, octopuses, crabs, fish, and tons of animals we've never even seen before. But after the submarine is done exploring under the water, there's one more thing it needs to be able to do. Maybe you've already guessed what it is. We know how submarines dive under the water, but how do they get back up? Well, remember how submarines bring along extra air? If there are people on the submarine, they can use it to breathe, but it's not only for breathing. When it's time for the submarine to go back up to the surface, it pushes air into the ballast tanks and water out. That makes the submarine lighter for its size, so it can float up to the top of the water.